In the previous video, we were given a detailed overview of familiar concepts to pave the way for understanding and using business components. From the transaction structure with its logic, and by logic we mean controls for duplicates, not only primary key, but also candidate keys, referential integrity, most of its rules and some of its events, a kind of data type similar to an SDT but much more powerful is obtained. Then, it'll be enough to define in almost any program a variable of that data type and manipulate it, which is what we'll see next. This variable, in its structure, will be handled similarly to an SDT, but it'll also offer methods for doing something specific to a transaction. Loading from the database, inserting, modifying, deleting. All of this by executing the logic of the transaction, and then obtaining the generated messages and the results of success or failure. The way to obtain that kind of data in the knowledge base is simply by turning on the business component property of the transaction. We'll start by creating a simple procedure that will modify to implement a more complete requirement later. Let's not pay attention to the name right now. We'll start with something very simple. Suppose we want to insert a new tourist attraction. The first thing we must do is create the business component of the attraction transaction, so that it can be used in any object in the knowledge base. Therefore, we go to the transaction, and among its properties, we'll find the one called business component. It's set to false by default. We'll change it to true. At first, we don't see any effect. However, if we save, we see this in the navigation listing. If now we go to the procedure and define it in a variable named attraction, we can see that because we selected a name matching that of the transaction, a data type of that name has been automatically used. What data type is that? If we select the variable properties and open the combo, there's a business component group that for now only offers one value. Not coincidentally, it's attraction. Here's where we see the effect of having enabled the transaction property. The data type business component attraction was created in the KB. It's available and can now be assigned to any variable. Having defined this variable in the procedure, memory space is automatically reserved to load all its elements as an SDT. So, if we insert the variable and type a period, in this window, we'll see the names of all the transaction's attributes, among other things. This is so we can use them in the structure, for example, by assigning them a value. In this way, we could do this. If we wanted to insert the Forbidden City tourist attraction, as we saw before when we used the transaction, we'll have to complete the data. We don't need to assign a value to the identifier, because it'll be auto-numbered. The name of the attraction will be, we know it's in China, it has the identifier 3, but what if we're wrong? We'd better look for that identifier with the find formula, because one thing we're sure of is the name of the country, China. That name is an inferred attribute in the transaction, so we don't have to assign a value to it here to insert the attraction. We know the city's Beijing, so we find its identifier and assign it to the business component element and also remove the inferred element. We assign a value for the category ID, looking for the one named monument. And we won't assign any value to the photo and address. So the variable is loaded with the data of the attraction we want to insert in the table. All we have to do is insert it. To do so, we have the insert method of the business component variable, which, as we can see, will return a Boolean value, true if it could insert it, false otherwise. We can just invoke it, and it'll try to insert a new record exactly as the transaction does. That is, executing all the rules and validations. If it succeeds, then the variable will be loaded with the ID given by the database and all of its own and inferred attributes. However, we should be aware that although the record is already in the table, it's in an unstable state. If there's a power outage or system crash for any other reason, that record will be gone when the database is reestablished. This is because databases allow us to insert, edit, and delete records as if at a logical level. Whenever it seems convenient, we must indicate that all those operations we've been doing can be accepted. This is done with the commit command. Therefore, if the insertion was successful, we commit. This is the action of making a commit on the database, that is, indicating that these operations should be fixed or made permanent in the database. When a commit is executed, all operations performed between the previous and the current commit will be accepted. Just as we have the commit operation to accept all those actions, the opposite one, called rollback, which allows us to undo everything that may have been done after the last commit. Here, we could make a rollback if the operation was not successful. But it won't make much sense here, because if the operation was not successful, we could assume that the record was not even inserted, so there will be nothing to undo. To quickly run this procedure from the developer menu, we set it as main object. And with the HTTP invocation protocol, we press F5. If we open the Work with Attractions element, we'll see that we already had attraction 7 for the Forbidden City, which we had inserted earlier through the transaction. Let's delete it. The identifier with value 7 will be lost. It won't be given again to the next attraction entered, which will be 8, as we'll see now if we run the procedure. Since it has no output, we don't see anything in the browser. But if we go back to Work with Attractions, it has actually inserted the Forbidden City. Let's delete it again, to run the procedure again. But this time, we'll add another attraction besides that one. For example, Notre Dame Cathedral. So, we should insert it here. We no longer need the information that the variable had. Actually, we need to at least clean it up to make sure nothing's left behind when we load the cathedral's data. One way is to ask for new memory for the variable, and it's done this way. Okay, now we have it insert the data. Asking for new memory is important. If, for example, we had not assigned a value to the category identifier, in order to leave it empty for the Notre Dame Cathedral, it would have been loaded with the value that we assigned before. Therefore, it's always good practice to ask for memory before completing the data of a business component that we're going to insert, even up here. Finally, before running it, note that in this case, we inserted the first attraction and we'll commit if that insertion was successful. Let's do the same with the second one, and commit. But we might want to commit only once, after we've inserted both attractions. Or, we could even try to insert the second attraction only if the first one was successful. For example, in that case, it would be like this. Here we'll only commit when the first and the second insertions were successful. It could happen that the first one was successful and the second one was not. Then, the record of the first one will be saved in the database, but it won't be committed. So, maybe in that case, when the second one is not successful, we don't want the first record to remain in the database. And then, we would use the rollback command. Let's run it. Let's see the attractions. We'll run the procedure. And we'll go back to work with attractions. Now we have 9 and 10. What if now we wanted to change the category of the Chinese wall so that it's no longer a monument and becomes instead a famous landmark, as well as change its name by removing the. Let's leave the previous code with comments, so that these two attractions are not inserted again. If their identifiers weren't auto-numbered, the insertions would fail because there's a duplicate key. But this isn't the case. We need to make an update, as we would do with the transaction. First of all, we need to load the variable with the attraction values that we want to change. We know its ID is 2, so we invoke the load method of the variable by passing it the key 2 as a parameter. When running this, it'll go to the table to find the record 2. And if so, it'll load the variable business component with all values, its own, the inferred ones, and formulas, as it happens when executing the transaction. Of all these values, we need to change 2, the name of the attraction and its category. All we have to do is have the variable update this data in the table. To do so, we have the update method. When invoking it, exactly as in the transaction, all the rules, formulas, candidate key uniqueness, and referential integrity controls will be run. And if everything went well, the record will be updated in the table. And of course, the variable will be loaded with the current data. Again, we could ask for the result of the update to, for example, already perform a commit. Let's try it. We'll run the procedure and check the attractions. Note that it's been modified. To complete the operations, what if now we wanted to delete an attraction by code? For example, delete the Great Wall. As we do in the transaction, we first have to load attraction 2 in the variable structure, and then simply give the order to delete. This is done with the delete command. We cannot repeat this enough. When this method is executed, all the transaction logic will be executed in delete mode, including the referential integrity controls. Therefore, if there were related information, such as city tours featuring this attraction that we would want to delete, then in that case, referential integrity control performed by the transaction and by the business component will prevent it. An error will occur and the record will not be deleted from the table. However, if there are no errors, the record will be deleted. The variable will be loaded with the data anyway, in case we want to do something with them. The delete method does not return the result of the operation. So, to find out whether it was successful, we'll have to query it explicitly, using the success method. The opposite of the success method is the fail method. And, for example, commit the deletion there. In other words, permanently delete the record. This method can be used after any operation, for example, after load, to know if it found the requested record in the table. Let's try what we've seen. We run the procedure, and note that record 2 has indeed been deleted. And what happens if we run the procedure again? Nothing happened. Why is that? In this second run, attraction 2 no longer exists. Therefore, it has not been loaded or removed. What if we now tried to reinsert the Chinese wall, but forgot to enter its name? Let's try it. We'll run the procedure. We open Work with Attraction. and we don't see the new attraction inserted. Of course, we forgot to enter its name, and the error rule we had declared is being triggered, preventing that record from being added to the table. If we had done this through the transaction, the user would have received the message we specified in the error rule. Where was that message when we tried to insert it through the business component? The transaction has a screen to show errors to the user, but the business component does not. Consequently, error handling is also left to the developer. How do we obtain them? The KB Explorer has a group of references, which we'll talk about another time. But it will always contain a GeneXus module, with functionalities already implemented to be used in our KB. In particular, there we'll find an STT called Messages. We can see it's a collection of items consisting of an ID, a type, and a description. The type is also predefined in the module. It's numbered and indicates the type of message in each case: warning, error, information, debug. Every time an operation is executed on a business component variable, we can obtain the collection of messages generated by that operation with the getMessages method. We'll have to define a variable of the data type returned by that method in order to manipulate its result. For example, for now, just to be practical, let's show the result in a PDF file. We'll run through the collection of messages generated with the forIn command, which allows running through collections, among other things. For this, we'll define a variable of the data type of the message collection items. And for every message of that collection, we print it in the output. Let's enter the output file rule, and we'll try it. We run the procedure, and here's the output. Only one item was obtained in the message collection, with an empty ID of type 1, which is an error. Its description is exactly what we entered in the error rule of the transaction. If we look at the syntax of the error rule, we see that it allows a second parameter, which is optional. This parameter will allow defining the ID of the error for the business component's message. For example, we'll assign it this value. If we try now, and there we can see it. Let's do one last test. Let's modify the rule so that it's no longer an error, but a message. Also, let's enter a non-existent country identifier as country ID. In order to see how the insertion fails due to the referential integrity control, let's try it. When trying to insert, 3 messages were displayed. The first one is a warning message, and it would not have caused the insertion failure by itself. However, the second and third ones could have caused the failure because they're of the error type. The internal ID is this, and the message displayed to the transaction user when the country integrity fails is, not coincidentally, no matching country. Also, a referential integrity error will be thrown when trying to insert the city, which depends on the country. Having said that, we've seen the most relevant aspects of updating the database with business components. In this way, we saw that from the transaction, it's possible to create a data type that is like an SDT, but that allows operations to be performed on the database from methods. These operations preserve the logic of the transaction. Although we didn't go deeper into it, clearly not all the rules and events of the transaction will be incorporated into the business component. The ones that have to do with the interface obviously will not. The parm rule is not taken into account either. In addition to allowing these operations on the database, we can check the result of the last operation performed, as well as obtain the messages generated in a collection. There are even more methods to study. For example, the mode method returns the mode of the business component, if it's insert, update, or delete. The save method, which, depending on the variable's mode, will try to insert if the mode is insert, or update if the mode is update. And also, the insert or update method will always try to insert, and if it fails because of a duplicate key, then it'll try to update. The insert, update, delete, and insert or update methods can also be applied to business component collections. So, if the attractions variable were a collection of the attraction business component, in this case, a collection of 3 attraction items, applying the insert or update method would be the equivalent of running through the collection and applying the method individually to each item. The result will be true if the individual results were all true. The last important thing to mention is that a variable of business component type can be used in any object that has some section of code, not only procedures. This means that we can update the database, for example, from a panel event that requests or displays data to the user, as we'll see. It can also be done from events in transactions, although in that case, there are some limitations that we won't see here. In the following video, we'll apply everything seen here in an example. You may skip it, except for the final part, because there, we'll implement again the procedure created here so that it inserts a new tourist attraction category, tourist site. We'll change all the Beijing attractions that had the monument category and assign it the new one. We'll see how to do this through an interactive web panel, which offers to do the above, but also to undo what was done, leaving everything as it was. And lastly, we'll create another web panel that will allow us to remove the information from both tables, category and attraction, leaving them empty. This will be taken up again later, so we strongly recommend watching at least this final part. Of course, there's a lot more to see, but we'll leave that for the next level. If you're interested, you can search for videos related to this topic in the GeneXus Analyst course.